Well, hello again everybody. Well, I'm wondering if any of you can tell what's on the bench today. Can any of you tell what this is? Have you seen one of these before? Well, what this is actually quite an early car radio. I'm not exactly sure what date it is. I'm kind of thinking, I think this is using those Locktool style valves. So I think this would be probably, would we say 1940s? Later 40s, I'm not exactly sure. I'm going to go for some time in the 1940s. So this is a car radio and it's actually made by Ekco, the Ekco company. And for those playing along at home, it's type CR60. So I'm afraid this radio is in pretty poor condition, I guess, like a lot of things that are automotive. It's probably been outside and it's got very, very rusty. Underneath on the tag strips here, we've got quite a lot of capacitors, and they're probably some of the most disgusting and melty capacitors that I've ever seen. Now I'm trying to decide whether or not to do some kind of restoration on this, and to be honest, I think it's probably more work than I want to do, but it would be quite nice to do you know, like a cold start video just to see if we could get the radio to do anything. Well, I've already spent a couple of hours working on this, and you can see that I've already removed, well, there was a cover over here and there was a cover on the bottom, and I kind of wish that I hadn't removed some of these covers, because every time I remove the covers I find more melted wax capacitors and more mess. I mean, one thing is that unfortunately, again, it's got that rubber covered wiring, and inside it's all the actual insulation has come off the wiring, so probably we've got a lot of wires shorting out as well. Well, I'm sure you all know that valves tend to have quite a high voltage power supply to them, so you're perhaps wondering how car radios could work, because, you know, cars were either 6 volt or became 12 volts a little bit later. Certainly we haven't got the 220 volts which some of these valves need. So how did we get from 12 volts to 220? Well, these radios actually employ something called a synchronous vibrator. So this is a synchronous vibrator here. It looks a bit like a big capacitor, and it plugs in. And also we've got a transformer here. So the way it works is you actually get the DC, the 12 volts DC from the car battery. It goes to what they call this vibrator, and this vibrator basically, well, it vibrates. What it does, it actually turns a supply of voltage on and off to this transformer. It turns it on fairly quickly, and effectively it chops up the DC. So what you have here, you've got the centre tap of the transformer, which is connected to the plus 12 volt supply, and then there's another 2 wires which are either winding. So what actually this does is the vibrator, it actually pulls the windings on either side of the centre tap. It alternatively pulls one to ground, then the other to ground. So this transformer does work a little bit in reverse compared with normal mains operated sets, in that you've actually got a primary winding which has just got a few turns on it, and then you've got a secondary winding which has got lots of turns on it. So what actually happens is the vibrator chops up the DC, and what the transformer does with those chopped up DC, multiplies it up into high voltage AC, and then we've just got a normal rectifier tube here which rectifies that. But as I say, I fell at the first hurdle in that this vibrator it's a mechanical device, and they call them vibrators for a reason. It's because they make a buzzing noise, and they've got kind of a pendulum inside which swings backwards and forwards very quickly, and it makes a vibration. So that's why they call these vibrators. And it does appear that, I don't know if we can just get this vibrator out. The problem that I've got is this vibrator has actually burnt out. The actual has switch contacts inside it, and those switch contacts they just burnt away. Let me bring you in so you can have a closer look. So our vibrator here, really it is just a special kind of relay. So what you've got is you've got the coil of the relay here. That's where the relay coil is, and that gets energized with 12 volts. And what that does is there's like a, can you see that little piece of, there's a little piece of steel on there that gets attracted to the magnet. So normally this 12 volts is being supplied to the coil of this solenoid. So and it's supplied via a set of contacts here. So when you switch the vibrator on, the contacts down here are actually closed. What happens is that energizes the coil, which pulls this little kind of pendulum over, pulls it to one side, that breaks the contact, and then it drops back again. So it actually opens and closes the contacts very quickly, and makes this vibrating sound, and yeah, and that's what chops up the DC. But as I say, the problem with this one is the contacts are just burnt away on it, and although I've done my best to clean the contacts and get it working again, it's very intermittent. Sometimes it works, sometimes it doesn't. You've got to try to clean the contacts, and then you've got to bend them so that they have just the right amount of pressure to able to do the switching that they need to do. And yeah, I can kind of get it to work. If you kind of give it a bit of a tap, it'll start working, and then maybe it'll stop. But sometimes when you just put 12 volts on it, because this contact here is bad, it doesn't always supply 12 volts to the coil to get it started. And I say, I've tried cleaning it and rubbing it with some emery paper, but yeah, unfortunately it just doesn't seem to want to come good. So ideally I'd really need to replace this vibrator with a new one. That's what we should do. It's not designed to be serviceable. When they actually fail, you just throw it away and put another one in. But of course, yeah, these might have been common in the 1940s, but unfortunately they're not as common today. Now, back in the day, a lot of cars were actually positive earth, but I guess this is slightly unusual because it's actually negative earth. So one of the wires goes to the chassis here, and let me see if I can put 12 volts on the right place. So hopefully you can see that our vibrator is doing what its name suggests. It's now vibrating, and as well as just vibrating, what it's actually doing, it's chopping up the DC, and it's supplying pulses of DC to the transformer, which is just to the right of it. So hopefully that transformer should now be stepping up that low voltage 12 volts pulse DC, and it should be stepping that up to high voltage AC. So let's go in search of that high voltage. So this radio will suffer from all the problems of a typical valve radio. So we're probably going to have a lot of bad capacitors, and what that'll be doing is that is going to be pulling down our DC supply. So we've got a rectifier. I'm not sure where that rectifier tube is. I think it's yeah, it's that tube there actually. So let's just go probing and see if we can find some high voltage. Hopefully we should find some. Well, there's minus 20, that's no good. Okay, so there we go, we've got 133 volts there. Now unfortunately we probably want something like double that. That's actually on the low side, so that could just be being caused by all these capacitors being bad or leaky. But I actually think that probably this vibrator isn't working properly. I've got a feeling only one side of the transformer's perhaps being pulled to ground. I don't think the vibrator's working as it should. So yeah, I think that's going to be a problem. I think what I'll try doing is I'm going to try and just pull the rectifier tube out, and we'll just have a look at the AC coming into the anode of the valve, because I think that the HT needs to be a couple of 100 volts for this radio. So I guess we're looking for more than that on our anodes. So let me just see if we can measure that. So we haven't got the, we're not going to be producing any DC now because we pulled the rectifier. So I think we can just go off the anodes, which I think is that one. Good, so there we go, we've got 500 volts. So we've gone from 12 to 500 volts. So hopefully you can see that. I think what we'll do is we'll go ahead and we'll just put the rectifier back in. And we'll switch it on, and I think this capacitor here, I think this is a main smoothing capacitor. Unfortunately this part of the circuit is just chopped off the edge of my diagram, so I'm just guessing, but I think that'll be the case. It'll probably take a moment for the voltage to come up. Probably don't want the meter on ohms, do we? Okay, well we did have good voltage for a moment there. I actually saw it come up, and then it looks like the some of the valves started conducting, and then I think the HT dropped away. Well, I've been digging away a little bit off camera because I've been trying to find out why the HT voltage of this radio is low. it seems to come up quite high until the valves start conducting, and I've actually found quite a few problems which I'll probably try and explain. Now, one of the problems that I found was just things like the suppression grid capacitor here, smoothing capacitor, had gone short circuit, so that was drawing power, and these two capacitors here had also gone short circuit, and these two capacitors are wide across the secondary, the high voltage output of our transformer. So I just did a little bit of Mr. Snippy Snip Snip, and I snipped them off, and the voltage did come back a little bit, but not enough. So I've been continuing to investigate what's wrong. I did also find that the actual the output pentode valve here was drawing excessive current. It should be drawing, I think the nominal value says about 30 milliamps. Well, this was drawing about 50, and it appears that there was a problem with the negative feedback. It's quite interesting the way this output valve works. In fact, none of the valves in here have cathode resistors on them. So they don't have any form of negative feedback. So the way that this radio produces negative feedback, you've actually got the common line from the transformer here, what would normally be a 0 volts, but it doesn't actually connect direct to the chassis. It actually connects to the chassis via a 120 ohm resistor here, and what that actually allows you to do, you drop a few volts across that resistor, this 120 ohm resistor, and that actually produces in effect a minus supply with reference to the chassis. And what you can do with that minus supply, and it's about minus 4 volts, you can actually use that minus 4 volts as a grid bias for the valves here, because as you know, if you put a positive voltage on the grid of a valve, it will conduct very, very heavily. Normally you want to put pretty much a minus voltage on them to keep them switched off. So again, rather than having a cathode resistor in the output pentode, it does it here with just one resistor, which is in the power supply line. So it took me a little bit of time to figure that out, and what I did find is the minus grid bias smoothing supply has some resistors. It has a CR smoothing network. Now both the resistors in that smoothing network had gone very, very high, so rather than producing, I don't know, minus 2 volts of minus grid bias, it was actually only producing about 0.5 volts. So I've gone ahead and I've just bodged in some new resistors, and yes, we've got something like now the correct grid bias going to the output pentode. It's not spot on, but having doing that, I'm still finding that it does seem to be drawing still a little bit of excessive current. But I also think the vibrator that we've got in circuit here, it just isn't doing the job. What we've got here on the primary of the transformer, that's actually connected to plus 12 volts all the time, and then what the vibrator does, it actually pulls each half of the centre tap primary winding. It pulls one half of that winding to ground, which is on that side, and then it pulls the other half to ground on that side, and it swaps over pulling those two windings to ground alternately. Now the reason that they choose to do it like that, it's because if you actually only just pulse the transformer across one of its windings with DC, what you would actually find is a DC magnetic field would actually build up in one direction. The transformer would become magnetised, and as it becomes more and more magnetised, it becomes less and less efficient to the point where it just wouldn't work anymore. So what they're actually doing is they're magnetising the transformer in one direction when they pull one of the windings to ground, and then they actually magnetise it in the other direction when the other winding gets pulled to ground, and it's constantly swapping from one winding to the other. That's what you need to do to make the transformer operate efficiently. But unfortunately, with our vibrator circuit here, that's not what's happening. What I've found is one side of the transformer is being pulled to ground properly as it should be, but unfortunately the other side isn't. Now I'm afraid there's an awful lot of switching noise, which is actually the back EMF from the transformer. When you actually take the supply off the transformer, you get a huge back EMF as it tries to get rid of that magnetic flux, and that's why we're getting these big spikes, and they make it quite difficult to see what's going on. You see, it looks very noisy, but hopefully I can see there that here the waveform, it's up at 12 volts and the winding is being pulled down there. You can see it's being pulled down to ground because this line here at the bottom, that's our ground, and that's our 12 volts, so it's being pulled down to ground. So that's working as it should. Let's have a look at the other side of the winding. Well, it looks much more distorted now, but hopefully what you can't see is there's nothing on the 0 volts reference now. So it looks like the other side of our centre tap is only actually being pulled down to about half the supply. Well, in fact, I don't think it's actually being even pulled down to that. We're actually just seeing an effect from the other half of the winding, which is giving us this strange effect. So carrying on, the next thing that I really would like to do is, I'd probably like to plug in an aerial socket to this receiver, but unfortunately that's going to prove pretty much impossible because the aerial socket plug should go into there. But if I take my little spyglass and have a look into there, the only thing I can see is broken wires and damage, so there's no way I can actually inject a signal into this radio. So we're going to have to try to do some dismantling, I think, to see if we can get this thing apart. And it's actually very difficult to get apart. Everything is, as I said before, all the insulation is crumbling off the wiring. Every time you touch a wire, more insulation falls off it, and everything is seized up because it's really just very, very rusty. So, you know, I'm making all my excuses now because I think we're going to struggle to get at anything. In fact, I bet I can't even get this knob off here. So what we've got to do is we've got to get this coil box arrangement. This is the box here that does all the tuning for the radio, and that's where the antenna connector should have gone. So we've got to open this up and we've got to take it out to allow us to put a clip lead in and connect to the aerial socket. I think that that's going to prove almost impossible. Now I've got my tool of last resort, which are these Exolite drivers, which seem to be growing fungus on them, and the plastic has gone quite manky. And for some reason, when the plastic starts to degrade, it kind of rots for some reason, and it gives off like well, I was going to say a vinegar smell, but it's actually much worse than that. It smells as though these have been stored up my bottom for a large period of time, but no, they haven't. But they do stink. Well, let's face it, this screw was never going to come out, was it? So I'm afraid I'm faced with now taking this into the garage and try and use a pistol drill and just see if we can drill the remains of the screw out. Well, as you can see, unfortunately our tuning select switch here did put up quite a fight, and I had to break it to get it off. So hopefully you can see that I did actually manage to drill the grub screw out, and I actually drilled not just through the grub screw, I actually went a fair way into the shaft as well because I got a bit carried away. Now I did try using WD-40 and other penetrants to try to get this knob off, but unfortunately I couldn't do it, because the one thing that you can't do is, this was installed on here like this, and the plastic knob actually had like a steel insert on it. It wasn't brass, it was actually steel. And so because this shaft is so rusty, the two parts of metal, they're just kind of rusted, cold welded together. And one thing that you can't do is you can't just start pulling at this shaft, because what would happen if you just kept pulling on this knob trying to get it off? Probably could have got it off that way. What it would have done is it would have just pulled out, it would have smashed the switches in this coil box, because yeah, they're delicate, these things, and you can't put too much force on them. So in the end I did have to make the decision just to basically smash the knob off, and then I could get at the steel collar that was holding it on and very gently encourage it to come off. But it took a long time, and yes, unfortunately this is the result, a bit of a mess, but don't worry too much, it was a mercy killing. So hopefully, I said earlier, this isn't actually what I would call a restoration video. I'm not doing any restoration today. It's kind of more, it's more what I'd call a cold start video. I'm just trying to see if we can get some music, some notes to come out of this radio. I'm not expecting it to work properly, and I'm certainly not doing a full restoration on it. It's in an awful condition. Okay, so this is what I will call the coil box assembly. So this was the tuning shaft here. Now there's something quite interesting about car radios in general, and especially this one. Now a lot of radios that we're used to playing with, domestic radios, they use a large variable capacitor to do the tuning, but for whatever reason automotive receivers didn't go that way. So these are what they call permeability tuned, or another word for it is, some people call it slug tuning. So rather than using a capacitor to tune to tune certain coils and things to resonance. What they actually do is they use inductance, and they use variable inductance. Now, I'm not exactly sure why they chose to use a variable inductance in place of a capacitor. I suspect it was something to do with, if you imagine that a variable capacitor, it's got lots of very close fitting aluminium sheets which have to pass each other with very fine tolerances. Well, I'm guessing in a car, those very thin aluminium sheets, those capacitor plates, the vanes would be vibrating, and maybe if they went over a big bump, they would vibrate enough to touch together and short out. So I think that the reason that they choose to use inductors is because it was for mechanical considerations. They just considered that they would be a lot more robust, and every time your radio went over a bump, you wouldn't have to retune it as you may have had to have done with a variable capacitor. So, you know, that's the reason behind it. I can't really tell you any more than that. That's my understanding of that's why car radios, and in fact even the more modern car radios, use permeability tuning, and they didn't use a variable capacitor. Let's have a cheeky peek, see what we can see. Okay, what I can see is total buggeration. I can see a mess. Okay. So what we had in here, we had an inductor and some kind of filter or trap, I think it is. Let's see if we can just take that out. And I can see that all the windings that are on this inductor, they are all, they just smashed, they're all broken. Which is great. Let me bring you in so you can look at that. I think we'll probably be able to get this radio to tune without it, so I don't actually know if it's worth trying to wind a new coil. Let me show you. So hopefully you can see, here's our little inductor which we've taken out, and somehow it looks as though all the windings have been cut through on this, and it would be very, very difficult to count the number of windings. I'm amazed that anybody could actually do quite as much damage to this thing as has occurred. Pretty much all the windings have been cut through. I wonder if I can cut them through. Yeah, if I cut them through completely and then I can count them, I can pull them off individually and count them, and maybe just take a piece of wire and we'll try to, what we'll do is we'll try and wind a new one. Now this is only, I think, a UHF filter. I think if we just connected the antenna connection right to it, I think it would probably still work fine. But if we can just rewind this with some fine wire, it might be still might be fun to do that. Let's see if I can count these windings. Okay, there's 1, 2. Okay, so I quite painstakingly had to remove all those windings, and I've counted them, and it turns out that L1 here, our little UHF filter, had 27 turns on it, so we may go ahead and rewind one, or we may not. I'll have to see if I can be bothered. Well, seeing as we've gone to the trouble of taking out this coil box, we might as well take a closer look at it. So you can see this is the side that actually points out. It points towards the radio operator. So this is the main tuning shaft here, and what this is, it's a preset radio, so it's not got variable tuning on it. It's got a number of presets on it, and as you turn this, it clicks from one preset station to the other. And the way this radio is tuned, as I mentioned earlier, it's actually tuned via these inductors here, so I'm not exactly sure if each of these relates to a station. Maybe some of these are for tweaking the IFs and stuff like that, or trimming the antenna, but I'm guessing, let's just say that maybe there's up to 1, 2, 3, 4, maybe 5 preset stations on this radio. And when you actually just turn this switch here, what you're actually doing is you're bringing in different combinations of these inductors. Now unfortunately I've not really found out very much information about how this actually works and which inductor affects which of the tuning selections. I'm not sure about that, so I think there's going to have to be a little bit of trial and error involved. So let's see if we can just take the back off it, and what we're expecting to see is a lot of inductors, a lot of slugs. Now the reason that they call them slugs, or they call these particular types of things, they call them slug tune. The reason that they call them is because they have lumps of ferrite rod, which they call slugs, and you actually tune the radio by adjusting the position of the ferrite cores within these inductor coils, within these wound coils. So you can see we've got a selector switch here, and you can see this selector switch is actually wired to all these banks of inductors. So depending on where you've got the selector switch turned to, where you've got the wiper set, it'll bring in various combinations of these. But I guess the interesting thing is, as I mentioned earlier, this is all tuned using this inductor slug tuning. There isn't a variable capacitor in sight apart from this one, which is nothing to do with this radio. So all the tuning is done by inductors, and I think that's quite unusual. It's something that I've only ever really seen on other car radios. I think it was probably done on a few domestic radios, but certainly it is quite an unusual tuning arrangement. Well, I've gone ahead and I've reassembled everything, and I think what we'll do is we'll just power it up using my external power supply, and we'll see if we can tune a station in. I've got no idea if this is going to work. Maybe it'll work, maybe it won't. Your guess is as good as mine, so if you want to place your bets, please do so now. And I think I'm going to run this off my external power supply, because we already know the vibrator's bad and it's not really generating very much HT. And I think we probably want something around 200 volts. So yeah, I'm afraid I'm going to cheat. That was almost boring, wasn't it?
Conduct by the FA in the wake of the defeat to Chelsea. It pledged to integrity of the game's VAR official and the county championship.